creating potential energy. We're really happy this whole thing's going to be on mute.
So, we're going to call these crayons your counterweight, because, you know, they could be a counterweight. If you have them down here, they have less potential energy than if you have them up here, because up here, it has more capacity.
Mm-hmm. Yeah.
Hi, we're in a car. So, assuming I'm actually driving, I'm not that good of a driver. I'm not going to drive at constant velocity. I'm going to slam on the acceleration pedal or on the brake, and then my velocity time graph's not going to be a straight line. It's going to be like a curve or a acceleration is going to equal the slope of that line. Okay, here we have a heavy stapler and a really light paperweight. Right now, both of them have 0 kinetic energy. Let's say I throw this one across the room. I threw it at 5 meters per second. But if I throw this one across the room, which I'm not going to do, at 5 meters per second, this one will have more kinetic energy because it has more mass, and kinetic energy is equal to 1/2 mv squared. Okay, let's say I am the Earth, nice and massive, and this is me, nice and tiny. So, according to Newton's second law, I attract this little buddy as much as this little buddy attracts me. Let's talk about work. I have a tennis ball. I throw my tennis ball. Look, I caught it. So, since we live in a non-ideal environment, the tennis ball was going at a slower velocity at the time it finished than the time it started. Since work is equal to the change in kinetic energy, tennis ball actually did negative work. Shame on you, tennis ball. So, that means